BluntCut MetalWorks, October 29, 2017. This very thin hunter here is 0.75, again, 75,000 inch thick. And the Rockwell hardness is 69.25. And I'm testing extra acute angle. In this case, this is less than 10 degrees per side. 1/8 inch up the bevel, up here, above the sharpening bevel, is 12,000. So, and I ding a little bit and try to measure the edge shoulder, but the edge shoulder is somewhere 4,000 or something like that. I think there's geometry going on there. And I sharpen this with all the way up to extra fine DMT, and then I strop at about 8 degrees per side on a quarter micron diamond, and it's sharp and have a little ding, but that's okay. And if I do one swipe, you can see the stubble and skin come out of my chin here. With the wind, cutting test is a little bit more challenge, but I can just push it. I think it pushed almost 90 degrees cross grain here. I usually don't bother that much, and because it's less than 10 degrees per side, let's call it 10 degrees per side, and we'll see how long it will last before it fails. And so, and I guess I can do a quick paper towel test. Kinda not easy here. It cut, and okay. You see how stable is this edge. Really thin cardboard here. Now this is USPS post office box here. I don't want to pick these things up, so it will cut that. And I pressure cut carefully, as you know this, but toward the end I will be a little bit more and there's some sort of not pine, some furniture something, but I'm going to pressure cut it. So extremely smooth piece, curve, and so early on I'm going to be careful. I think the objective of this video is to see what it would take to provide a microchip, maybe big enough to catch and tear this phone book paper, because you don't have really that much steel in the behind the edge of the edge there, really thin. And this is scissor 1/2 inch. I soak in water because it makes it harder, a lot harder to cut. And so also it doesn't fly around as much. So I'm going to do. Just pretend I'm cutting vegetables. Did I say this is 10V? Okay. And my heat treat is 251. So instead of all these bits flying everywhere. Since it's wet, it's kind of nice and confined. So that rope cutting, I pressure cut it, so it's not, there's no impact. And so, let's test the so let me remove this picture. Okay. So rope cutting, not a problem at this point. So I just going to, I guess, I mean, I will contact in something a little harder contact, and so but I'm thinking here, if I'm going to, well, this thing is over here. If I were doing something and I would do a little bone contact. And I expect, I mean, again, this is so thin, and so it already snapped. It hit it, it snapped, so I think the edge already suffered. That's one thing about. Now you can see it right here. So when, of course, if I were doing more control, then it wouldn't be so. And that was an impact, and so of course this knife not for impact, but I just want to see non-impact. That was about test. Let me try to do a non-impact here. Get contact. There you go. That better. Tore about an inch from the heel. Yeah. It's stuck in there. Okay. So that is more of a contact. It's not an impact. And you go and look at the two area, the impact here, but clearly, you can actually see quite clearly you lost part of the edge. And while the impact to the bone back here, you can see many, many little microchips. And for the, how thin is it? It's very, very thin. Okay, I get that. Okay, that may be this better view. Give it a zoom. And so I'm going to, so now this part damaged, this part microchip, I would try this cut in this outdoor pressure cut, the outdoor electrical wire here. Okay, it went through. There's a strain of copper in there, and I can see it reflect light. What this test is, I mean, why would I want to do something this thin and this harsh? I mean, instead of to see the damage, does it produce a big crescent moon chip, or it just end up with these fractured chip, and this smaller chip here. And now, because it's so thin, we see how it's sliding paper here. I will do slowly. Now that is the bone contact, and because it's so thin, you can see it did go right through the paper there. And now they're going to do, that is the impact. And the electrical, again, let me do that slowly. Enter, bone contact, smooth, bone impact, a little electrical right there, and smooth. So the damage is not as extensive. Well, I think it's not extensive. Oh yeah, there we go. I can see it pretty much lost. It lost the because it's so thin. It's sort of a zero grind here for the whole bevel. So anyway, this what I sort of want to test and see how it will turn out. Okay, I do that quick cutting board impact. This is the end grain cutting board, so it's not as harsh. But we'll see how it's holding up. It doesn't. I put the camera in a bad light today. It doesn't produce any, again, any chip. When the impact here, because you have actually wider air, the PSI is not as high as when you're doing bone contact. Bone contact, you concentrate in a very small area, so the PSI is very high. But when I'm doing, it's a lot more metal, and it's no problem chopping to the cutting board. And let me quick test it, and we call it good. And that was it for the end here I chopped. And I think that was an electrical cutting tape back there too, but when the wind pick up, it's really hard to cut. All right, well, thanks for watching.